In addition to simple random sampling, there are other sampling methods commonly used for surveys. So here's our list. We've talked about random samples, simple random samples, and now we want to focus on systematic samples, stratified samples, and cluster samples. They all have two things in common. The first is that every member of the population has a known non-zero probability of being selected. This means that it's known, it's not necessarily equal, but it's something we could determine in advance, the probability of being selected, and it can't be zero. And also that random selection is involved at some point in all of these types of samples. So let's start with the systematic sample. With the systematic sample, we randomly choose a starting point and then select every kth subject in the population. And so that would be chosen, every 10th, every 100th, every 200th, whatever your resources and the situation call for. And so with a systematic sample, here's an example of one. So say we want to sample 8 houses from a street of 120 houses. So that would mean if we go to every 15th house out of the 120, then we would be able to get our 8 houses. And so we randomly select a starting point. Okay, so within the first 15 houses, if we randomly start at 11, then now this determines every 15th house that we will stop in and survey. So that is systematic sampling. Okay, stratified. Let's look at what stratified sampling is. With stratified sampling, you subdivide the population into at least 2 different subgroups so that subjects within the same subgroup share a characteristic. Then you draw a sample from each group. Now, this is frequently done in the medical field. They'll subdivide the sample into males and females and then draw samples from that. Let's look at another example of stratified besides medical field. Say we want to conduct a survey of 200 college students at a university, and so we list the students by class: freshmen, sophomore, juniors, and seniors, and then select 50 from each class. And this way we're sure to get, a representative group from each class. Otherwise, we might take a chance and get mostly juniors and seniors, and perhaps we want to have a better representation of the freshmen and sophomores in our group. So if we just randomly selected college students, we can't guarantee we'd have a good representation from each class. So we might use stratified sampling. Okay, the next type we said we were going to look at is cluster sampling. In a cluster sample, you divide the population into sections, then randomly select some of the sections and choose all members of the sections for the sample. Now, cluster and stratified sound similar. Let's make sure we understand the difference. In stratified, you subdivide into 2 groups that share characteristics, and then you draw a sample from every one of those groups. In cluster sampling, you divide up into sections, but then you just randomly select some of the sections. We don't randomly select just the males if we have males and females, or randomly select just the sophomores and juniors if we have all 4 classes. In stratified, you sample from all of your subdivided groups. In cluster, you cluster them and then select some of those clusters. And then notice you survey all the members in the clusters you selected. In stratified, you draw a sample from each one of your groups. Okay, so there's a big difference here. All right, let's look at an example of cluster sampling. Suppose the Department of Agriculture wishes to investigate the use of pesticides by farmers in Tennessee. A cluster sample could be taken by identifying the different counties in Tennessee as clusters. A sample of these counties, these clusters, would then be chosen at random. So all of the farmers in those counties selected would be included in the sample. See, it can be seen here that it's easier to visit several farmers in the same county than it is to travel to each farm in a random sample to observe the use of pesticides. So instead of just getting all the names of the farmers in Tennessee and randomly selecting some to visit, it would be much more logistically simple and easier to handle if you select counties and then go to every farmer in the county. Finally, there's a sampling method that's used that I didn't mention yet because it's not random and it's not desirable, and it's called a convenience sample. And this is any time we collect data just in the easiest way. It involves no randomness, and it's not considered a valid way to sample, but it's often done. And let's look at an example of what we mean by convenience sampling. Say we have some sociology students who want to conduct a survey to learn more about a particular sociological issue, such as the connection between certain beliefs about society and income. The students might distribute the survey to their classmates because the members of the class are easy to access and they will likely get a high response rate. Everybody's going to help everybody else, so yeah, we'll all fill out the survey for each other. However, this one sociology class is not likely to be representative of the society at large. So we want to avoid this method, but we need to be aware of it because it is frequently used. It's just easier to get samples from the most convenient people, whoever's right there. So in summary, as we move into the data analysis portion of the course, we will primarily be concerned with simple random samples. However, we want to be able to recognize the types of sampling used in the statistical reports we encounter in our daily lives.